Hello everyone, welcome back to my channel. My name is Anthony Gitalasa. For this day, we will summarize the activity 6 of the networking one in NetAcad. But before that, we need to read the introduction of this chapter. Okay, so we need to go to the chapter 6 introduction and read it. Chapter 6 Network Layer. Network application and services on one end devices can communicate with application and services running on another end devices. How is this data communicated across the network in the efficient way? Okay. Then the protocols of the OSI model network layer specify addressing and processes that enable transport layer data to be packaged and transported. The network layer encapsulation enable data to be passed to be destination within a network or on another network with minimum overhead. This chapter focuses on the role of the network layer. It examines how it divides network into group of hosts to manage the flow of data packet within a network. It also covered how communication between network is facilitated. This communication between network is called routing. Okay, so we are done in reading the chapter 6 introduction. We need to go to chapter 6 summary and conclusion before we summarize this chapter. Okay, so the network layer or the OSI layer 3 provides services to allow end devices to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processing: the IP addressing for an end devices, the encapsulation, the routing, and the de-encapsulation. Okay, so the internet is largely based on IP version 4, which is still the most widely used network layer protocol. An IP version 4 packet contains the IP header and the payload. However, IP version 4 has a limited number of unique public IP addresses available. This led to the development of IP version 6 or IPv6. The IP version 6 simplified header offers several advantages over IP version 4, including better routing efficiency, simplified extension header, and capability for per-flow processing. Plus, IP version 6 addresses are based on 128-bit hierarchical addressing as opposed to IP version 4 with 32 bits. This dramatically increases the number of available IP addresses. In addition to hierarchical addressing, the network layer is also responsible for routing. Host requires a local routing table to ensure that packets are directed to the correct destination network. The local table of a host typically contains the direct connection, then the local network route, and the local default route. The local default route is the route to be default gateway. The default gateway is the IP addresses of a router interface connected to the local network. When a host needs to forward a packet to a destination address that is not the same network as the host, the packet is sent to the default gateway for further processing. When a router such as the default gateway receives a packet, it examines the destination IP addresses to determine the destination network. The routing table of a router stores information about directly connected route and remotely route to IP network. So if the router has an entry in its routing table for destination network, the router forward the packet. So if no routing entry exists, the router may forward the packet to its own default route if one is configured, or it will drop the packet. Routing table entries can be configured manually on each router to provide static routing, or the router may communicate route information dynamically between each other using a routing protocol. So in order to route for router to be reachable, the router interface must be configured. So to enable a specific interface, enter the interface configuration mode using the interface type and number global configuration mode command. So this chapter is all about the four basic processes of network layer, such as the addressing and devices, the encapsulation, the routing, and the de-encapsulation. So the addressing and devices, so it must be configured with a unique IP address for identification on the network. Then next is the encapsulation. So the network layer encapsulates the protocol data unit from the transport layer into a packet. Okay, then next is the routing. So the routing can provide a service to direct packet to a destination host on another network. Last is the encapsulation. Okay. So the encapsulation is when the packet entries at the network layer of destination host, the host check the IP header of the packet. Okay. Also in this chapter, the IP version for packet header consists of field containing important information about the packet, such as the version, the differential services, the time to leave, the protocol, the source IP IP address, and the destination IP version address. So the version, so it contains a 4-bit binary value set to 0100 that identifies. Next is the differential services. So it is a 8-bit field used to determine the priority of each packet. Then the time to live. So it contains a 8-bit binary value that is used to limit the lifetime of packet. Next is the protocol. So protocol is used to identify the next level protocol. Then next is the source IP version 4 address. So it contains a 32-bit binary value that represent the source IP version 4 address of the packet. And last is the destination IP address. So it contains of a 32 bits binary value that represent the destination IP version 4 address of the packet. Okay, so that's all for this day. I hope you you understand what I'm saying. So see you in my next video and bye bye.